Hey, geometry students. In this lesson, we're going to be talking about how to graph a circle from an equation. Now, you can see at the top of this page, we have this general formula for the equation of a circle. I'm going to take a moment to mention that this is not Euclidean geometry anymore. Remember, Euclidean geometry is geometry that can be done with a compass and a straight edge. And the most important thing about a circle in Euclidean geometry is that it's just a set of points the same distance away from a center, and we're able to draw it using a tool like a compass. This is actually taking a circle and putting it on a graph using an equation. Euclidean geometry wouldn't have really used equations like this. You would have used proofs. Okay, so we're stepping aside from Euclidean geometry to do something more technical. And it's really cool that we're able to do this, graph something this way. But just wanted to point out that this is not Euclidean geometry, it's something else. Now, we're going to be talking about the equation of a circle, which can be written like this. And in its simplest form, it's just x squared plus y squared equals r squared, where x squared and y squared are the key components to making a circle, and r squared is the square. It squares the radius. R is the radius, and whatever value that r squared, like let's say it's 36. If r squared is 36, that means the radius of your circle is 6. Okay? We're going to add in these extra dimensions here. So we're going to say x minus h and y minus k, because h and k are going to shift the circle on the coordinate plane horizontally for h and vertically for k. Now notice that the natural state of the equation is x minus h. If we have x minus a number, whatever number that is shifts it to the right. If it's x plus a number, that number shifts it to the left. Y minus a number shifts it up, which is counterintuitive. You think minus, you think down, but the natural state of the equation is minus. So whatever number we plug in for k, if it's y minus k, it shifts it up. If it's y plus k, it shifts it down. Right, now, we're going to learn best in this lesson by actually graphing some of these and by actually working some problems. So let's get started on the practice problems right away. If m x y is a point on a circle centered at the origin with a radius of 3, and P is the center of our circle, what is PM and what is the equation of the circle? Okay, so let's answer this one. What we're going to say is that PM equals 3 because it's a radius. P is the center of the circle. M is a point on the circle. The distance from the center of a circle to a point on the circle is the radius, which is 3. The equation for the circle. Now, here's the thing. If it's centered on the origin, I don't need h and I don't need k because h and k are 0. So this is going to be the simplest equation for a circle that we could have. Okay, and here's what it's going to look like. It's simply going to be x squared plus y squared equals, and now I need to take the radius and square it, 9. X squared plus y squared equals 9. Hey, let's just go to GeoGebra and make sure that we're actually doing this right. So x squared plus y squared. Notice that the graph is a circle that has a radius of 3 units. So this works out as the equation for a circle with the radius r squared here being 9. The radius itself is 3, r squared is 9. All right, let's go back to our lesson. Let's do letter B. In letter B, we need to write an equation to relate all the x and y coordinates of points that lie on circle A with a radius of the square root of 2, which is centered at the origin. Okay, so this is just going to be a equation for a circle. X squared plus y squared, okay, just like before. Now equals, here we have to be a little bit careful, but not really if you think this through. The radius is the square root of 2. I need to square that. So it's going to equal 2 equals 9. All right, let's just check our answers so far. So for this one, x squared plus y squared equals 2. The square root of 2 times the square root of 2 is 2. In the previous one, PM equals 3 and x squared plus y squared equals 9. So we're doing this exactly right. Let's go on to letter C. Write the equation for circle B in our figure over here. Okay, now this one, notice, is not centered at the origin. It doesn't have its y coordinate of the center is 0, but I need to shift the x coordinate. So here's what this is going to look like. This is going to be x minus 2 is going to shift it to the right 2 squared plus y squared. I don't have to shift the y coordinate at all because it doesn't go up or down, equals, and let's see, the radius of this is 1, 2, 3, 4. So this is going to be the radius squared, 16. That should be the right equation. There it is. Letter D. Circle C is concentric with circle B. That means that they have the same center. Okay, concentric means they have the same center point. Uh, and has a radius 3.5. Write the equation of circle C. Okay, so that's still referring to this. Circle C has the same center, but it has a radius of 3.5. Well, here's the difference. The only thing that's going to change is my radius value. Okay. And let's see, the way that this is going to change. So this is going to be the exact same equation, except instead of 16, it's going to be 3.5 squared. Now, I don't know what 3.5 squared is off the top of my head, so I'm just going to punch it into a calculator. 12.25. So it's going to equal 12.25. Take my answer, and we answered that one exactly correctly. All right, on to letter E. For letter E, I'm not actually going to graph these. We're just going to talk about the graphs for E and F. The equation of circle D is x squared plus y squared equals 6.25. Actually, you know what? I can put this one on this graph here. Let's do that. What I need to know is what is the square root of 6.25, right? Because 6.25 is the radius squared. So 6.25, but I need to do square root of 6.25, and I find that that value is 2.5. So if I were to graph this, now I know there's nothing shifting it away from the origin. So this is going to be a circle on the origin with a radius of 2.5. And if I were to draw that here, it would look like, oh man, I'm going to have to move it over. Okay, so it needs to be a little bigger. There we go. And 2.5 is right there. Let me just get rid of the fill here. There, that's going to be the circle. It's centered on the origin and it has a radius 2.5. I'm just going to make that circle red so it looks a little different from the background. And there we go. That was letter E. Letter F is another one that I'm going to put on the graph here, except this time I have x plus 1 squared plus y minus 3 squared equals 4. So this one is going to have a radius of 2, but it's not going to be centered on the origin. From the origin, I have to go, let's see, x plus 1 means I go down 1. So its center is going to be there, down 1 unit. And over to the right, because it's minus 3, it goes over to the right. Oh no, I did it wrong. Hold on. I mixed up my x and my y. Because it's x, it goes left 1, left 1. There we go. And then up 3. 1, 2, 3. That's where it's going to be. Okay, now I've got it center at the right place. You can see the crosshairs here put the center at negative 1, 3. 1, 2. Oh, I need to go up one more. Hold on. 3. There we go. Okay, so negative 1, 3. Now I need to shrink this down so it has a radius of 2. So its center is here. That means it only needs to be shrunk just a little bit because it was 2.5. So let's see if I can get its radius to the right amount here. Sometimes it's hard to do this in a drawing because it wants to make it the same size as other things. But actually that worked out really well. So there's my circle. Notice that the center is -1, that's expected, plus 3, so 1 comma 3, and then a radius of 2. Letter G. This coordinate grid shows the position of the lines of a basketball court. The center circle crosses the half court line at A point A is 4719, point B is 4731, okay? So AB is a diameter. Now, what's the question we need to ask ourselves is what is the length of the diameter? The x coordinate is the same, the y coordinate is different by 12. So that means that the diameter of this thing is 12. I don't care about the diameter for my equation of a circle. What I need is the radius. The radius is going to be 6. So I'm just going to keep a note of that. So for letter G, I'm going to note that the radius of my circle is 6. Now, here's the other thing. I also need the xy coordinates of the center. And if I know this is a diameter, the center is going to be right in between. So the center is going to be at the point 47, comma, and then 19 plus 6 is 25. That's going to be halfway up from 19 to 31. Okay? So that's going to be the center of my circle. Now, if I know the radius and the point to the center of my circle, I can easily write an equation. It's going to be x minus 47 squared, can't forget the squared, plus y minus 25 squared. All right, got to get this squared in there. Equals the radius squared. The radius is 6 equals 36. That should be the equation for my circle. Let's just check and make sure we got it right. X minus 47 squared by y minus 25 squared equals 36. That is how you work these circle problems. You are ready to apply this to the homework problems.